Hello everyone, and in this session we will quickly assemble the third assembly, that is the machine wise assembly. In the previous sessions, as we created the models, and now in this session we will create this assembly, and with the help of that assembly 3D assembly, we will quickly create the assembly drawings and finish off this machine wise assembly activity. So here is the machine wise assembly. In the initial session I have shown you, this is a very simple assembly where this body is fitted with this screw rod, and this movable jaw is moving with this jaw grips uh, assembled with the help of countersunk screws. Mm. So we will quickly go to the assembly session, as we have already created the um, models. I will just open the solid edge portal, go to assembly module, and my folder is in desktop. Already it is there in the desktop. If it is not visible, you just make sure that you are in a particular path. Okay, now call one by one part. The first part, the body, just select this and drag this body has been arrived into the assembly mode, and here you can see in path folder 001 has been added. And then next, before adding this, I feel you just insert this screw rod, so that it will be helpful you to fix the movable jaw. So I will insert this screw rod and just drag this, and I will make this space exactly to this. Uh, Now check with the front view. The hole is not aligned. Uh, Show this reference planes and assemble this, align this plane by this plane. Now it is aligned. So um, hide your reference plane. Okay, now bring your movable jaw. I will hide these assembly planes also. Whenever they are required, I will just show them and use them. Otherwise, it will create a confusion while selecting the faces for mating and aligning. Okay. So next part is bring this movable jaw, align your cylindrical shaft to this screw rod, and then this bottom surface to the top of this, and keep the front view, and just move this, keep it in a convenient space. So just refer this drawing from this edge. It is little bit of distance not mentioned. As per your convenience, you keep it. So now bring all other parts. This is jaw grip. Just back face, you select it, and uh, make this with contact with this surface. It has become reverse. So here you can see flip icon. You flip it, it will become reverse. So now align this cylindrical axis to this axis. Okay, now see these parts have been aligned or not, and there is an interference between this plate and this part. So I will again call this jaw grip. Once you flip it, you mate this surface. I will recall that part again. Okay, now it is I think fine. You just go to this alignment of this axis to the hole, and then select the bottom face and then select it. Now I think there is no issue with this. They are perfectly fine. Use this and use the wireframe, and whether make sure that your holes have been arranged on the axis are collinear or not. Just check it. Okay, it looks fine. And recall this one more jaw grip will come on this face on the body. Okay, now you align this, and this bottom surface will just make contact with that step face. Keep this front view and view it in a wireframe, so it looks perfect. Now bring other and this fourth part is screw. Wherever these countersunk holes are there, you just you, okay, now made this top face with this jaw grip. Okay, now go to assembly pathfinder to I will make patterns instead of calling it again and again, because it is called 4 5 times, 6 times it is called in the assembly. So I will pick this, make a pattern, select this parent part, select the holes and select the parent hole. Just right click, you will be having the replica of this, and you cannot make a pattern over here because you have to recall it again, and wherever these patterns are there you can use it. Again you have to call this for this plate, again you have to one more, you have to call it and just align it onto this hole. Flip this, it has gone here. I will just select the top face of this screw and bring it. Now you see it is perfectly fitted in, and now use the same pattern icon, select this entity and make press on this pattern parts icon, select the parent part and hole features, select the parent hole, just right click on it, the instance is created. So now go to part library again, which are the other parts to be brought in. A washer, I think washer will come and align with this face. Just mate with this face, align the axis, that's it. And then this I think 8 will sit first, then followed by 7. I will bring 8, that is nut, align the mate the face. Now align this axis. Okay, now bring 7, that is another nut, and then mate this and align this. So the last part is this clamping plate, which is coming um, clamping part. Just hide this body so that we can comfortably place that clamping plate here. And now the bottom face should come in contact with this. Flip this, and then now you align any of the axis of this screw with this, and then align this side face with this. That's it. And now it is perfectly, you can see. Top view, and I will use this common views to check whether they are aligned or not. Okay, it looks in a perfect shape. And then okay, here also there are screws. Then you have to call this 4 again here and zoom it little bit and mate this top face with this. And again go to Pathfinder, create this pattern by picking this parent roles. You just make a instance. Now you just show your body, main body of this vise. Now it is I think all parts have been arranged and assembled. Now you can save your assembly. Okay, go to file, save command with .asm extension. You can name it. We'll give the name machine wise assembly, in which is will be saved in your folder which you have created in desktop. So after this, just go to create drawing, file, go to file, create drawing, and in the using this custom icon you can check this whether you need this view or this view or some other views. Okay, uh, I will just create this view, front view, and then quickly remove this sheet and set this to A4 sheet and bring this view here and try to accommodate and try to reduce the scale. It is 1:1 now. I will make it 1:2. so that because in the examination more than one view is being asked, that time you have to reduce the scale. Then now create the balloon callouts and part list. Uh, just it is a usual procedure. Uh, you just rearrange it by giving different sizes, by customizing your material schedule. Width you change it little bit, reduce it 35, give some 15, reduce this size so that your material schedule will come within your sheet layout area. You can change the fonts as well, make it 2.5, and balloon colors auto you reshape it by breaking out. uh, you change the color if you want and rearrange them. And just place this wherever you feel comfortable. These sheets have to be within the uh, all the things, attributes, dimensions, balloon color should be within the drawing area. Okay, now this drawing is been done. Then now you save it as machine-wise assembly.dft file. It will be saved in your folder. You can check at the end here in your folder all the parts, 3D assembly and 3D assembly drawing should be there in your folder. Okay, with this we will finish off this machine-wise assembly drawing creation and model creation and assembly creation. We will in the next session we will take these are the three assemblies which are frequently asked. Uh, the other three assemblies are there. They are their part list is compared to these assemblies. There are more parts are there, and with the they most of the students feel them as very difficult. Um, but the same methodology is being used. No matter how the drawing becomes complex, as you use the same methodology for specifically for these machine parts, and read the drawing thoroughly, dimensions, everything, then there will not be any much issue. Actually, this is a very scoring subject. Only skill is required and little bit of drawing knowledge with which you can score it very well and have a good knowledge. And the CAD as skill is very much required for a mechanical engineer, because civil engineers they use for the layout purpose simple AutoCAD is enough for them. For a mechanical engineer, uh, as you go into aerospace industries, automobile industries, now they all are involved in uh, shaping, sizing, conceptual design. These CAD activities are going iteration wise, and very much demand is there for you to once you learn these CAD skills and conceptual design, there are huge demand in the field of aerospace and automotive design activities. So keep practicing. Uh, we will start the next assembly in next session. Till then, I will say bye to you. Okay, we will see you in the next session.